Hello and welcome to this physics video, Magnetic Field Forces on Moving Charges, U12.MFFMC3. And today we will be deriving and applying the formula for the radius of the circular path of a charge that moves perpendicular to a uniform magnetic field. And alright, so to start off, the magnetic force of a particle that moves in a uniform magnetic field in a circular path, that magnetic force acts as a centripetal force. So what we're going to do here actually is set the magnetic force formula, set that equal to the centripetal force formula, since they really are the same thing. And when we set them equal to each other, we get what r, the radius, is going to equal in this situation. So after we set QVB equals to mv squared over r, we finally get, in regards to r equals mv divided by qb, which is the radius of the circular path equals the mass of the particle times the velocity of the particle over the charge of the particle times the magnetic field. So let's try a problem out. A proton with a mass of 1.7 times 10 to the negative 27 kg has a charge of 1.7 times 10 to the negative 20 coulombs. This proton is moving at a speed of 2.0 times 10 to the 6th meters per second. The magnetic field has a magnitude of 7.0 times 10 to the negative 5th teslas. What is the radius of the circular path of the charge? So let's begin by bringing down our equation. And let's put in our given values that we have here. We have a mass of 1.7 times 10 to the negative 27, a velocity of 2.0 times 10 to the 6th, and that is going to be all over the charge, which is 1.7 times 10 to the negative 20, times the magnitude of the magnetic field, which is 7.0 times 10 to the negative 5th. So what I'm going to do is put all of that into my calculator. Alright, 1.7 times 10 to the negative 27 times 2.0 times 10 to the 6. Oh. Okay, we get that. Now we have to divide this value by the charge times the magnetic field magnitude. So that's 1.7 times 10 to the negative 20, negative 20, times the magnitude of the magnetic field, which is 7.0 times 10 to the negative 5th. And we get this value, 1.4 times 10 to the negative 5th. That is the length of this radius. And that's going to be measured in the SI unit of length, which is meters. So there you have it. To find the formula to find the radius of the circular path of a charge that moves perpendicular in a uniform magnetic field, you set the magnitude of magnetic force with centripetal force. You get your equation. You plug in the values you get, which is going to be the mass, the velocity, the charge, and the magnitude of the magnetic field, and you can find the radius of the circular path. So, thank you for watching, and I hope you enjoy the video.